Good morning. Yes, we will start in a short time. We're just waiting for all people to PM. Good morning. Good morning. We will start in a short. I don't know. Okay, maximize this. Can you see my screen? Is it okay? Can you see my screen or? Okay, thanks. But I guess maybe it looks smaller. Yes, it's a small. Yes, correct. So I will try to see how can we fix it. Yes. So welcome to the third week of the course, and today we will cover some topics. Should we start now or should we wait a little bit? We can start now. I mean, today we will talk about some topics. We have some topics to cover today. Today we need to talk about sklearn. It's a very important library in machine learning in Python. We will use it for iris classification problem. It's binary classification. We will solve it. It's not binary classification problem, of course, because we have 3 features, target features. We have 4 inputs in Iris problem. We have 4 inputs and 3 classes, but we will select the first 2 classes and we will try to solve it. So we will try to solve it. I mean, we will try to develop a classifier for solving this problem from sklearn. We will plot the decision boundary of this problem. It's very important to know how to plot the decision boundary. We also, for training and testing, we will split the data into training and testing with shuffling. And also we will use a perceptron for multi-class classification. I mean, we can use a perceptron for multi-class classification. It's not for multi-class classification, in fact, but it's one approach which is called one versus rest approach. One versus rest approach. We will talk about logistic regression classifier. We will talk about logistic regression for Iris dataset. We will have this implementation. We will talk about separable and inseparable datasets. I mean, it's a problem. Sometimes when it's separable, it can be solved by a perceptron, for example. But when it's inseparable, in this case, we cannot use a perceptron for solving this problem. So we need to find a way to fix it. We will talk about confusion matrix, because when we, after training our model, it's very important to test your model. And after that, we will talk about multi-layer neural network, MLP, and MLP classifier in sklearn, and MLP classifier in Keras. So in fact, today it's a good lecture, and we will try to cover many topics today. So first, we will start with sklearn, or scikit-learn. It's a Python machine learning library offering a collection of machine learning algorithms from data processing, model selection, model training, fine-tuning, and evaluation. So this tool, in fact, in Python, it's a very, very important, and it's important that we know how to use it, because it makes life really very, very easy. I mean, we don't need to implement all algorithms from scratch, but those models are implemented here in this library, and we can just import it to our work space and just use it. So this is very, very important, and it has been developed by Google, and it's widely used, in fact. So as I mentioned before, most of your time in machine learning you need to spend with data pre-processing, and maybe 40% with model selections, training, fine-tuning, and evaluation. We have all those algorithms implemented here in sklearn. We just need to implement those algorithms and models. You don't need to implement each algorithm from scratch. But in the last 2 weeks, we tried to implement some of those algorithms from scratch. And it's important because we need to learn the concept behind it. We need to learn the math behind it and how it works. We will start today with this Iris dataset. We need to build a classifier using sklearn. We need to build a classifier using sklearn. And the Iris dataset, as you know, we have 4 features. We call it input features. So we have sepal length, width, petal length, and width. So we have 4 features, and we have 3 classes. Yes, it is recorded. It's recorded. I mean, I will share the link with you afterwards. So this Iris dataset, you can just open your mic, please. If you want to say something, you can just open your mic and let us talk together. So we will start with this Iris dataset. So first we need to, last time we uploaded this Iris dataset from a file. Now we need to import it from, Keras and sklearn also, they have datasets, and those datasets are, it could be customized datasets, so you can generate your own datasets, or you can use one of the public datasets. This one of the public datasets, which can easily download it from or import it from sklearn. You can just use it for testing your model. Those public datasets, they call it benchmark dataset, and those benchmark datasets, many people around the world have been using it. Lots of work has been published. So if you are developing a new algorithm, for example, it's important to test it with a dataset which has been tested before, so you can make judgment about the performance of your model. So if you are developing a new algorithm, for example, it's very, very important to test it with a public dataset or a benchmark dataset, so people can understand or can make comparisons between the performance of your algorithm and other people. because thousands of people has been working with those data sets. They have been developing algorithms, so it's easy to make comparisons using one of those benchmark problems. But if you are developing a new algorithm, maybe it's hard at the beginning to test it with a data set with your own data set, but you can just test it with a customized data set or a benchmark data set. So this data set here, it has, we have here 4 inputs, right? And the output, we have the target classes, we have 3 classes, right? We have 3 classes. Okay. Yes, so so we will start by implementing it. I wish if you can go to your Colab and start implementing, a classifier, maybe a perceptron. We did a perceptron before, and I want to plot the perceptron with you one more time. If we need to, okay, I can just. So, for example, if we need to build a perceptron for this problem, so we will have a perceptron. So, if we need to build a perceptron, it will be just a circle, and this circle, it has some inputs, correct? And we have one output. In this case, we have here x1, we have here x1, we have here x2, we have here x3, we have also x4. So we have 4 features, and the output will be the target feature. We can call it T, for example. So this is the target feature. So, a perceptron, we have 4 inputs, and we have a target feature. We have only a single output, and this single output must be binary classifier. So we can just select 2 classes. So for our problem, for example, so for our problem here, if we need to build a perceptron for classifying this problem, we have 4 inputs and we have 1 output. But the output, it's 3 classes. So the first 50 points, it's one class. The second 50, it's a second class, and the last 50 points are a third class. So a perceptron can be used only for linearly separable data, and it's a binary classification problem. So here we need to work with our data. So we will start here by loading our data. So we will use from sklearn pre-processing. We can import from sklearn we can import data sets. So we can get it directly from data sets here. So we import iris. So iris, it's a data sets.load iris. So we will select the first 100 points. So the first 100 points related to petal length and petal width, right? So we will select the third and fourth, the third and the fourth features. So if we will go back here, we will select the column C and D. We will select the column C and D, and we will select the first 100 examples. So the first 100 examples are related to 2 classes, Setosa and versicolor. So if we go back here, and the first 50 points are related to Setosa, and the second 50 points are related to versicolor. So we will select only the first 100 points. Last time, those points here, it's the float numbers. You see those numbers, it's 5.1, 4.9, 1.4. So it's different, right? So it's important to normalize or standardize. If you want to normalize, it will be x minus x minimum divided by the range. So if you want to normalize your, it's important. It's very, very important to normalize your features, because it will help your model to learn faster. And because of what? It's because of the activation function we use. So because we use activation functions, which squashes the input into 0 and 1, correct? Or minus 1 and 1, for example. So if you are squashing, it means you will lose lots of information. In fact, if you didn't normalize or standardize your data set. So here, all those data points, maybe it's number between 0 and 10. It will be smart if you can normalize to have all your features in the same scale. So how can we normalize? We have also a pre-processing function from sklearn. It's called the pre-processing. We can import, for example, a standard scalar. So a standard scalar, it will standardize your input features. So first we will import x and y. We will import x and y. You can plot it. You can do whatever you want. And after that, if you want to standardize it, you can just do standardization, for example. So in this case, it will have all input features will have a mean value of 0 and the standard deviation of 1. If you want to normalize, it's fine. You can just normalize. How can we normalize it? I mean, normalization also it's easy because in normalization we will we can just do yes, I will just
Hello? Hello?
okay. Oops. My screen is yes. So you want to
Hello?
just try to fix things in my yes, Ahmed, do you have any question?
You can hear me, Ibrahim?
Yes, please just open your mic and ask your question, please. Okay.
Yeah, my mic is on.
Okay. My yeah, you can hear Ahmed, but I cannot hear, in fact. So I need to check my setting. But just feel free, please, to ask your questions. Ahmed, your mic also is unmuted, so you can just ask your question, please.
Hello? Hello?
I cannot hear you. Okay, so
Hello?
Ahmed, can you say something?
Yes, I'm saying. Yes, Ibrahim.
Yes, Ahmed, please ask because I cannot hear you, in fact.
Okay.
So just to check if your mic is fine. The rest can, okay. So it's only me who cannot hear you.
Ibrahim, can you hear me? I guess you cannot hear anyone.
I need to run something in my computer to be sure that it's... Hello? So, Ahmed, can you say something?
Hello? You cannot hear us.
No, so it's working. I mean, I don't have any problem. But I cannot hear you.
Yes.
Anyone else can ask a question, please, so we can check if my system is fine. Maybe Amir, Andreas. Anyone can say something, please, to be sure that I can hear.
Hello, testing. 1, 2, 3.
Andreas?
Hello.
Maybe I have a
Yes.
problem, right?
Okay.
It looks like that I have a problem. But you can hear me, correct? Okay. So okay, we will talk about this. This example, and I will give you some time to implement it. And after that, maybe after the break, I will restart my computer and fix the problem. So now we will go back to the example. So we will upload our data set, right? We will use this sklearn. It's easy to use. Just from sklearn import data sets. You can get iris from data sets. So it's datasets.load iris. You can get X and Y. X consists of 4 features, and Y consists of 1 target feature. And the target feature here, it consists of 3 classes, because we will use a perceptron for classifying this problem. In this case, we need to, we cannot use a perceptron, but because we need to use a perceptron here, we will select only 2 features. We will select only 2 classes. So if I selected the first 100 points, so if I selected from 0 to 100, it means we are selecting the first 100 points, and the first 100 points are related to 2 classes. The first 2 classes are Setosa and Versicolor. So it's important before solving your problem, you need to do this step all time. You need to standardize your input features or normalize it. How can we standardize? I want to write the formula for you. So the formula, it's x minus mu divided by standard deviation. So standardization, it's easy. So in fact, you can use a library. You can use this function, which is called standard scaler, or even you can just do it by yourself. You need to calculate the mean value, and you need to calculate the standard deviation of your input features, and just use the formula x equal x minus mu divided by standard deviation. Yes. No, I cannot hear you, in fact. Okay. Okay, yes. So now we need to import a model, right? Now we need to import a model. So how can we do this? Just a model called the perceptron. I mean, we are lucky here because we have from sklearn linear model a perceptron. Perceptron, it's a type of linear model. We know the decision line will be omega x plus p equals 0, correct? So this is a decision line. So it's linear model, in fact. So the perceptron, it's omega x plus p equals 0. So we will import this perceptron. So model equal perceptron. We need to specify here maximum number of iterations, which is the number of epochs. So for example, I'm selecting 100. And this is a learning rate. You need to start with a small learning rate. If it is large learning rate, maybe your model will not converge. And it's just random state, because random state here, it's important because it's a from where we should get our random numbers. Model fit. So when we are, I need to start training my model. So it's called fit. So model.fit. We have x standardized and y. So the inputs to this function will be x and y. You can use x directly, or you can use x standardized. And the target, of course, it's y. If you want to find the predictions, so y prediction equal model.predict, and the input will be x. I mean, in this example here, I didn't divide the data into a training set and a learning set, correct? We need to do it training and testing. So it's important to divide your data set into a part for training and a part for testing. So I used the whole data set here for training and testing, just to make it simple. And after that, you can print your coefficient. When you print your coefficient, in fact, it's the weights and the intercept. So it's omega and b. So when we print model.coefficient and the model.intercept, we are just printing the weight values, and we are printing the intercept, y-intercept. If you want to calculate the error, so error will be mean value between y, mean value of the error. The error will be y minus y prediction square. If you want to calculate mean squared error, so mean squared error, it will be, you can get it using this formula, and you can just print it. So finally, I want to plot the decision line. As we mentioned the last time, the equation equation, in fact, the equation, it will be omega x1 plus omega 2 x2 plus p equals 0. So this is the equation of the straight line which we got. We have two classes here. We have the red class and the blue class, and we can find a line which divides my data set into two sections. So we are plotting the data, we are plotting the decision line. So the decision line will be this one, in fact. It will be omega 1, x1, for example. I can find first a range for x1. So x1, it will be all numbers maybe between -2 and 2, for example, right? All numbers between -2 and 2. So this is x1. I need to find x2. So in this case, x2 will be omega 1 x1 plus b, sorry, negative omega 1 x1 negative b divided by omega 2. So now we can find the decision line and just plotting it. And we have the code here. So please just go to this. I can run the code, this example. And but in this case, I will just share my whole screen. So I will share my screen with you so we can run. Think. So I will get, where is this? Can you see my screen now? So this is my example. We will just open it in Colab. Yes, Ahmed. Yes, no, we didn't select. No, we didn't select the 3 targets because I will show it to you in the code. So just step by step, please. So now we have this Perceptron Iris SCCI kit. We will run this first part, for example. Right. So now we are running. You can just run all sections together. Okay. So this is Iris dataset. So Iris dataset, we are loading the whole dataset. But from the X and Y, from the target features and the target for the target input targets and for the input features and the target feature, we have X and Y. So instead of loading the whole data set, it's 150 points. So it's 150 points. I'm selecting the first 100 points. And the first 100 points are, related to the first 2 classes. So are selecting from 0 to 100. So now we are just plotting it. So do you see we have 2 columns, and after standardization we have also the same 2 columns, but it's normalized or standardized. So now the standardized, which means it has a mean of 0 and variance equal 1. So this is the so we are not selecting the whole data set because the size of the data set it's 150 points. We are selecting the first 100 points, and the first 100 points are related to the first 2 classes. Cetotsa and Versicolor. So now we are converting the problem into binary, but of course we can extend it to multi classes. So it should be possible to, and we will have an example today where we are using also a perceptron for, where we are extending the perceptron for multi-class problem. So this is the model. We are just importing it from sklearn. And we got the error equals 0, which means the accuracy it's 100%. And this is the model coefficient. So we have omega 1 and omega 2, and the intercept equals 0, in fact. So we have intercept. I don't know how it should be, but we will test it here. So now we have our model. Maybe it's not 0, maybe it's a very, very small number. So now we have our model. So we have the we have 2 classes in the graph here. If you can look into the graph, I selected X, in fact, I selected X and Y equal to the first 100 points. So now we are selecting only the first 100 points, and I'm selecting one class equal 0 and one class equal 1, right? So now we have two classes. We have the red class and the blue class, and we have the decision line, which is the green line here. So I mean, there are many ways, in fact, for plotting the decision line. It's another way for plotting it is to generate values, to use grid, to generate a grid, to generate this mesh grid. So another way for, I mean, this one, it's very simple. I mean, this one, it's very simple and it's very easy to understand, but maybe it's too simple. But if you want to make something more fancy, you can just, you can generate values for x1 and x2 and use this mesh grid command. Using this mesh grid command, we will generate a mesh grid covering the whole domain, right? And for each point in this grid, we will run the prediction. We will find the prediction. So we will divide this one into grid. So we will divide. I mean, we will generate. I mean, a set of points covering all values between, for example, -1 and 1 here, and between -3 and 3, for example, correct? In x1 and x2, two features. And after that, we will use mesh grid to generate a grid, and we will run the prediction model at each point of the grid. So we will run here. We will run the prediction model, the same prediction model which we got at each point of the grid, right? In this case, we will have, I mean, we will have three-dimensional space. We can plot the decision boundaries in 3D. So in this case, we can use this contour plot, for example, or 3D plot, for example, and plotting this graph in three-dimensional space. So now we have the function, and we will run this function now for our model. So now we are plotting it. So now we have this fancy graph. So it should be possible. I don't know how to do it, but maybe you are better than me in programming, for example. It should be possible to, I mean, in MATLAB, it was easy. When you have this graph, you can just move the graph, turn it left and right, and so on. So you can have better view of what is going on, but not in Python. It should be done by a command here. So you need to decide if you want to rotate the 3D graph. But in MATLAB, it was just easy. You just can rotate, you can move your 3D contour graph, for example, or 3D graph, for example, to have better view of what going on. But this function, it's quite simple. You just, I mean, write a function, and in this function, you will generate data points for x1 and x2, because we have two features, right? You have two features. So I will generate set of point covering this one from minimum to maximum with a step 0.1. You will do the same for x2 also. You will generate points covering this one from x2 minimum to x2 maximum with a small step. And after that, you will use mesh grid. Mesh grid will generate a grid of points covering my space, input space. And after that, for each point in the graph, for each point in the mesh, we will run this prediction model. We have model.predict, so you will predict in which class. So I will generate a grid covering all my input space. For each point in that space, you will run the prediction model, and you will find in which class. So maybe this one will be blue class, so this one will be red class. And you will plot it, and you will plot your data points, of course. So finally, we can get this graph. As I told you, in this example, I used the whole data set for plotting my for training and testing my model, which is not correct, right? We cannot do this, in fact. So we're doing it because it's easy, but we should not do it at all. It's important to decide the training mode if you will go for hold out validations or cross validations and so on. And based on this, you need to decide how you will divide your data set. But if you want to split your data set into training and testing sets, we have a function. We have a nice function also in sklearn, sklearn.model selection. It's called the train test split, right? So this function, you can use this function to split your data set into a training and testing sets. So the input to this function will be x and y, and the test set size. So if you selected the test set size equal 0.3, which means 30% of your data points will be used as testing, which means the remaining part will be 70% will be used for training and validation. And this one, it has good advantage because it will shuffle your data set. It's automatically. will shuffle your data set before dividing it. So don't need to worry about shuffling because it will do it anyway automatically before dividing. And also it will try also to make it balanced data set, in fact, because we have to if you will use Stratify. So I have two versions here. So this version without this one, Stratify, right? This one without Stratify. So we will run it first. So when we run it, okay, do you see? It was shuffled, right? I'm just plotting y-test. So 30% of the data points will be used for testing and 70% will be used for training. And if you can see here, I'm just printing y-test. So this is y-test, which is shuffled, right? So it's some classes are one, some from first class, second class. So it's shuffled very well. And the proportion of class labels in the train and test, it will be in the this one. It's to see the balance. I mean, if your data set is balanced or not. So it's almost balanced, but to be sure, you need to use Stratify. So this is the number of classes in each. It's the portion of class labels in train and test sets. So for example, it's 36 class 1, 34 class 2, right? In the training. This one is the testing. So 40 from class 1 and 60 from class 2. How can we do it? Using this NP bin count. So bin count, it tries to count number of classes, unique classes in each data in Y-train and Y-test, because this is the one which has a target class. So we need to know if it is balanced or not. How many class 1 and how many class 2. Of course, if it's not balanced, your system will be biased against one of those classes, right? So it's important to be balanced. So in fact, this function, when it divides the data or generates a data set, a testing and a training sets, it's smart because it shuffles the data. It shuffles the data first because our data was not shuffled. I mean, if we look onto the PowerPoint, the data set was not shuffled. The first 50 points are related to Setosa, and the second 50 points versicolor, for example. So it's not shuffled. So we need to shuffle it before dividing your data set into training and testing. And if you want to be sure that it's balanced, we need to use Stratify. We need to use this command here. So when we use Stratify, yes, of course, yeah, correct. When we are splitting, but I'm just doing it as an example. I'm not training the model, so I will leave it for you. Of course, we need to divide. We are not dividing the raw data, but we are dividing the standardized one. So here we need to replace X, in fact, with X standardized, because X standardized, yes, it's fine. Yeah, we need to do it like this. Yeah. So it will be the same. I mean, no difference. But if you will use Stratify, you will be sure that your data set is balanced, which is really important. It must be balanced. So I need all classes to be represented in my training and testing data sets. So if you can look into it now, we have 35 class 1, 35 class 2 in the training, and in the testing we have 15 class 1 and 15 class 2. If it is possible to be balanced. But of course, if my data set was not balanced from the beginning, it will do its best to make it more balanced as possible. But if your data set originally was, for example, 80 data points class 1 and 40 class 2, so I mean there is no way to make it balanced, right? But also we need to test it, in fact. So we need to test it. So it's important before training your model, you need to split your data set into training and testing, and standardized. I mean, it should be standardized or normalized, but we cannot work with and I will explain later on today why it's very, very important to standardize or normalize your data sets. I mean, it's for many reasons. I mentioned that also last week, because maybe the values of some features will be higher, much higher. Other values will be very, very small. So maybe the neural network, for example, will try to how do you call it? It will give higher weight to some of those features and the smaller weights to other features. So it will classify I mean, the neural network itself, it will start classifying. So it will give more importance to some features and less importance to some other features, which might make problems to my model. So it's very, very important to have all features in the same range. It's very, very important. And I mentioned an example, for example, if we're talking about age, for example, and income, maybe income in millions and age in I mean 35, 40 years and stuff like this. So to be treated equally, those features, it will be more smarter to normalize or standardize your data set. To normalize it, the formula, it's easy. It's x minus mu divided by standard deviation. If you want to normalize, it will be x minus x minimum, x mean divided by, sorry, x minus x minimum divided by the range. And the range, it's maximum minus minimum of each feature. So we need to do this for all features. So in this case, I mean, my model will have better knowledge because we keep all information. In fact, we didn't discard any information from my features, and my model will have better chances to learn faster and to converge faster. So I will, we will wait. Maybe we will give you like 5 minutes, 10 minutes break. So I want you to go to the example. Yes, I want you to go to the to this code example and run it. And for example, start from this one. Add this, move this section, split your data set. So now you need to split. I mean, I didn't split my data set here. So just please start here by loading your data set, split. I mean, build your model, and train your model with the training data set, correct? And after that, test it with a test data set, and just tell me what is the accuracy. What is the accuracy? And you need to have two numbers: prediction error. You need to find the prediction error in training and testing. So those numbers are very important. Those numbers, two numbers, are very important. So I will give you 10 minutes. Please go to the code and start working with, start from that part. I mean, here we need to move that part here. So we need to split our data set into a training set and a testing set. Use the training for training your model, and use the test for testing your model. And you need to find the two numbers. The first number, it's the prediction error in training and the prediction error in testing. Yes, and I will, in this 10 minutes, we will try to fix, I mean, the sound issue. Yes.